Alright, so in this problem, I have 2 to the power of y plus 2 to the power of y minus 1 is equal to 48. So obviously, I want to find the value of y here. So for my solution, I'm going to start by rewriting my equation. So I have 2 to the power of y plus 2 to the power of y minus 1 is equal to 48. Now, if I have something in the form a to the power of m plus n, this is equal to a to the power of m times a to the power of n. So in this case, I have 2 to the power of y plus negative 1. So this can equal 2 to the power of y times 2 to the power of negative 1. So now I have 2 to the power of y plus 2 to the power of y times 2 to the power of negative 1 is equal to 48. Now I'm going to factor out 2 to the power of y. So I have 2 to the power of y times 1 plus 2 to the power of negative 1 is equal to 48. And 2 to the power of negative 1, that's the same thing as 1 over 2 to the power of 1. And 2 to the power of 1 is simply equal to 2. Now 1 plus 1/2 is 3 over 2. So I have 2 to the power of y times 3 over 2 is equal to 48. Now we want to isolate 2 to the power of y. So to do that, we have to get rid of this 3 over 2. And to get rid of the 3 over 2, we have to divide both sides by 3 over 2 to cancel the multiplication. So then these two cancel out, and 48 divided by 3 over 2, that's the same thing as 48 times 2 over 3. And this is the same thing as 96 over 3. And 96 over 3 is equal to 32. So I have 2 to the power of y is equal to 32. Now 32 is the same thing as 2 to the power of 5. So I have 2 to the power of y is equal to 2 to the power of 5, meaning y equals 5. So now to check, if 2 to the power of y plus 2 to the power of y minus 1 is equal to 48, so 2 to the power of 5, which is 32, plus 2 to the power of 4, which is 16, and 32 plus 16 is 48. So I have 48 is equal to 48, and this is right. Alright, so in this problem, I have a to the power of x minus 2 to the power of x over 2 to the power of x is equal to 15. So I obviously want to find the value of x here. So for my solution, I'm going to first start with a to the power of x minus 2 to the power of x over 2 to the power of x is equal to 15. And if I have something in the form a minus b over c, this is the same thing as a over c minus b over c. So this is a property of fractions. So for here, a to the power of x minus 2 to the power of x over 2 to the power of x, I can rewrite this as a to the power of x over 2 to the power of x minus 2 to the power of x over 2 to the power of x, which is equal to 15. Now obviously, if we have one number over that same number, it's going to equal 1. So these two cancel out, and I get a to the power of x over 2 to the power of x minus 1 is equal to 15. Now, I'm going to go ahead and add 1 on both sides because we want to get rid of this 1. So then these two cancel out, and I get a to the power of x over 2 to the power of x is equal to 16. Now, if I have something in the form a to the power of m over b to the power of m, this is the same thing as a over b to the power of m. So in this case, I have 8 to the power of x over 2 to the power of x, and notice how both the exponents are the same. So I can rewrite this as 8 over 2 to the power of x is equal to 16. Now, 8 over 2, that's obviously 4, so we have 4 to the power of x is equal to 16, and 4 to the power of what equals 16? 2. So I get x is equal to 2. So now to check, my original equation was 8 to the power of x minus 2 to the power of x over 2 to the power of x is equal to 15. Since x equals 2, I have 64 minus 4 over 4 is equal to 15. 64 minus 4 is 60. 60 divided by 4 is 15. So I get 15 is equal to 15. This is right. Alright, so in this problem, I have 25 to the power of x plus 5 to the power of x is equal to 20. So I'm going to first start by rewriting 25 to the power of x as 5 squared to the power of x. So I simply just substituted in 5 squared for 25. And I have this plus 5 to the power of x is equal to 20. Now, if I have something in the form a to the power of m to the power of n, this is the same thing as a to the power of n to the power of m, meaning I can switch these two exponents. So this is the same thing as 5 to the power of x to the power of 2. And I have this plus 5 to the power of x is equal to 20. Now I'm going to let 5 to the power of x equal to the variable y. So now if I substitute in y for 5 to the power of x, I get y squared plus y is equal to 20. And now I'm going to simply subtract 20 on both sides. So then these two cancel out, and I get y squared plus y minus 20 is equal to 0. Now I'm going to rewrite y here as 5y minus 4y. And I'm going to factor this by grouping. So first, from y squared plus 5y, I can factor out y, so I get y times y plus 5. And from negative 4y minus 20, I can factor out negative 4, so I get negative 4 times y plus 5. Now if I factor out y plus 5 from this, I get y plus 5 times y minus 4 is equal to 0, meaning y is equal to negative 5 and y is equal to 4. Now remember how we said that 5 to the power of x is equal to y. So to start, we have 5 to the power of x is equal to negative 5, and you can't take the power of a positive number and make it negative, so this is wrong. Now for y equals 4, we get 5 to the power of x is equal to 4. And to solve this, I'm going to take the log on both sides. So I get log 5 to the power of x is equal to log 4. And if I have something in the form log a to the power of b, I can move this exponent of b to the front. So it's going to equal b times log a. So in this case, I have log 5 to the power of x, and I can move x to the front. So I get x times log 5 is equal to log 4. Now if I divide both sides by log 5, these two cancel out, and I get x is equal to log 4 over log 5.